Alright guys, I'm going to go through some problems for some test review. First we'll look at a proof of proving that something is a rhombus. So obviously if we want to graph it we can do that. Let me plot these points real quick. As usual I'm not very exact with my sketch, but we know that to prove something is a rhombus I need to know its defining characteristics, which is 4 congruent sides. I should mention, I guess, that for each of these, you just want to pause them and try it yourself, and then you can see how you like my work. But obviously, if I want to show congruent sides, I need to find distances. So I should find the length of each side. So AB is the change in x squared plus the change in y squared, and that's 49 plus 16, which is 65. BC, change in x is 4, change in y is 7, and that gives me the same thing. CD is change in x is 4, change in y is 7, and AD is change in x, still 4, and change in y is still 7, which is square root of 65. So of course I need to write some sort of conclusion sentence, so maybe you could even say something like there are 4 congruent sides here. So your sentence, your some statement should say since ABCD has 4 congruent sides, it must be a rhombus, and we are done. We've done our stuff here. Let's go on to the next one. So this one has words in it, so I know you're probably already intimidated, but we can read. We're hiking, and we're hiking on a grid, which, believe it or not, I don't know. Sorry about that. Right? That's how our latitude, longitude, everything works anyway, so this isn't too crazy. I'm beginning my hike at 2:3. I am at camp at 14:8. Whatever, I'll call this A and B if you want. And I want to stop and have lunch 3/5 of my way from A to B, is what it says. So, basically, this is a fancy way of saying partition AB, segment AB, into a ratio of 3 to 2, or I can say, some new point divides AB by 3/5, something like that. Okay, so obviously we know there's 5 parts. I want to go find 3 of them, so we need to find the change in x and the change in y. So my change in x is 12. Right, I'm going 12 to the right. My change in y is up 5. Okay, so I need to go 3/5 of that way. So 3/5 of 12 is equal to 36 over 5, which is 7.2 for you decimal likers. And that's for my x. My y is 3/5 times 5, which obviously is 3. So this means that I need to travel 7.2 in the x direction and 3 in the y, and I started at 2:3, which means I'll land at 9.2, 6. That should be 3/5 of the way, and that's where we're eating lunch. Let's take a look at one more. So this partitioning segment stuff really is important for us to be able to do tomorrow. Okay, this problem, I don't know why it says it's number 1 again, but we can see here it's a little bit, may seem a little more complicated, but we have a regular hexagon. I have a coordinate 1, 3, another coordinate 2, 5. And these are consecutive vertices, meaning they're hexagons we know have 6 sides, and these are 2 vertices that are next to each other. So maybe it looks like this. Who knows which way it's facing? What I know is all 6 sides are the same, and these 2 points make up one of the sides. So if I want the perimeter, I'm going to need to find the length of this side times 6. All right, so let's find the distance from 1, 3 to 2, 5. Ultimately, that's all this question is asking, not nearly as hard as it seems. So I know I should do the change in x squared, which is 1, plus the change in y squared, which is 2. And the length of this one side of this hexagon is square root of 5. That means the perimeter is 6 times that length, which is 6 root 5. So again, there's a word problem that maybe seemed intimidating. It's pretty simple. Again, the key being we know how to deal with distance and length and perimeter. Here's another number 1, apparently. We want to find the midpoint of the diagonal AC for this rectangle. So I need this diagonal. Where is the midpoint? Well, I'm going to need the coordinates to be able to do that. A, it looks like, is -2, -4. C is 3, 6. So the midpoint for the x, I should do -2. I want the average of the x coordinates, which is -2 plus 3 over 2, which is 1/2. For the y coordinates, I want the average of -4 and 6, which is 1. So my point should be 1/2, 1. For those of you doing distance, I know that the change in x is 5, and the change in y is 10. So another way I can do this is I know that my midpoint should be half of those distances. So if I took -2 and added half of 5, I would have, that's 2.5, right? So I would get positive 1/2, which was the same answer. And I should add half of 10, that distance, which is 5, to my y coordinate, which was -4 plus 5 is 1. We should get the same answer we see here. Let's try just a Okay, so this says that we have vertices of one of the sides of a parallelogram. And I want to find the opposite side if I know one of the points. Okay, so this, I don't know what your first thought is here, but the key is, if it's the opposite side, what do I know about it? It is parallel. And I know a point. So what's this question really asking me for? Find an equation for a parallel line that passes through that point. No big deal. The first thing I need to do is find the slope. The slope of AB, of course, is change in y, which is 4 minus 2, over change in x, which is -1 minus 3, is 2 over -4, which is -1/2. There's my slope. If I do point slope form, I would have this point, that slope, right? So my y minus y1 would be y plus 3 equals the slope, which is -1/2, times x minus 0. Of course, that is no 0, so if I wanted to solve this for y, it would be -1/2 x minus 3. Okay, and that would be it. Just in case we find our y-intercept another way, if you did y equals -1/2 x plus b, and I plugged in 0 for x and -3 for y, I would get -3 as b and get that same thing. I think we have one more before we leave. All right, so this is the same figure from number 4, the one we found the diagonal and the midpoint. What if I wanted area and perimeter? So here, obviously, I want some side lengths. The length of AB looks like we're going up 1, 2, 3, 4, 5, 6. That's my change in y. I'm going over 1, 2, 3. So that's 36 plus 9 is 45. BC, we're going from -5 is my x to 3, so I'm going over 8. I'm going up from 2 to 6 is 4. So that's 64 plus 16 is 80. Obviously, I can simplify these. This is the square root of 9 times the square root of 5, which is 3 root 5. This is the square root of 16 times the square root of 5, which is 4 root 5. This is nice, because now that I've found these, I know the other opposite sides must be the same. So CD must be 3 root 5, and AD must be 4 root 5. So for perimeter, we're in good shape here. I should have 4 root 5 plus 3 root 5 plus 4 root 5 plus 3 root 5. Again, we're treating the square root of 5 as an object, and I have 4, 7, 11, 15 of those objects, so my perimeter is 15 times the square root of 5. To find area, I need to multiply my base times my height, or two adjacent sides, so my area should be 3 root 5 times 4 root 5. 3 times 4 gives me 12. Square root of 5 times square root of 5 gives me 5. And my area is 60 units squared. So I hope that helps and that we're well prepared for our test tomorrow.